There are over 750 new functions in Mathematica 10, which is the single largest increment of new functionality in any release of Mathematica to date. So we put a huge amount of R&D effort into this release, and I want to go over some of the highlights with you just briefly here. So a few weeks ago, we rolled out the Wolfram Cloud, which is an online environment that you can, where you can create notebooks, do computations, deploy Wolfram language code, all from your browser. And you can go now, today, and get a free cloud account at www.wolframcloud.com. So version 10 is completely cloud connected and cloud aware. So for example, you can open notebooks from the cloud, you can save to the cloud. So you can work fluidly between Mathematica 10 on the desktop and the cloud from your browser. We've put a lot of effort into making Mathematica more usable in version 10. And a big component of that is the code assist features. So for example, if I start typing a function name, I'll get a pop-up menu of function completions and choose one of those, and then I can choose a template of argument structures. And then you just simply tab between fields to fill in those values. And then if I start typing here in the position of a plot option, the command completion knows that I'm within a plot command. It only gives me options for plot. And if I select one of those, I get a further pop-up that has the right-hand side values for that option and even helpful thumbnails sometimes. So it's very easy now to navigate your way around the language and not have to remember all the option names and values. So a further usability feature, which I think for many is going to be the headline feature, is there is now multiple undo in Mathematica 10, and we're all very happy about that. Time series are now a first-class object in version 10, and time series modeling is highly automated and integrated with our random processes framework, so you can easily do sophisticated analyses and predictions of time series. Graphs and networks have been extended in two significant ways. First of all, you can now do 3D layouts of graphs, which make graphs like this octahedron, which are inherently 3D, much more intelligible. And graphs have been extended to accommodate multiple edges between vertices and mixed directed and undirected arcs in graphs. And behind the scenes, the traveling salesman algorithm has been significantly speeded up, so it will now deal comfortably with thousands of points on a path. We've added 4 new color spaces to image processing, which means that you have much more flexibility in doing color operations like blending and color negation. And all of the functions which previously worked on 2D images have now been extended to 3D images. So for example, you can find the components of this 3D image. We've put a lot of effort into data science in Mathematica 10. It's been a major focus. And at the root of that is this key value associative array, which functions like an ordinary array, but you can index it by keyword or by other expression. And built on top of that is a very powerful new data structure called dataset. And it unifies the concepts of hierarchical and relational databases in one object. So for example, if I have this data set of planets, then I can do relational types of queries on that, including operators like this length function, which will give me data which is not explicitly represented in the original database. We've put effort into making it easier to get data into Mathematica. So one of those functions is semantic import, which is an intelligent data import function. So for example, if I have this file of building data, a simple ASCII file, and import that with semantic import, I get this data set. And a number of things have happened behind the scenes. It's recognized that the elements in this data set are separated by vertical bars. It's recognized that the things in the third column are city names, that the things in the fourth column are country names. And it's built a data set which is indexed by the keywords, which are given in the column headers. So once you've imported that, you can immediately ask for the city that the first building is in, for example. And because it recognized that that city is a city, you get back a city entity rather than a city name, which is very valuable because there's all sorts of data associated with that, like population and latitude and so forth. And then finally, to get your data more easily out of Mathematica in the form of beautifully formatted reports, we've implemented this template mechanism. In the past, in order to make reports, you had the option of either doing it by hand with a notebook editor or doing it programmatically, which is not a trivial task. Now you have the best of both worlds. You can create a template notebook using the notebook interface that has slots in it and things to be evaluated. And then using that template, you can apply it programmatically to the information you want to appear in the template and create a nicely formatted report. So there are three completely new domains in Mathematica 10. The first of which I'm going to talk about is machine learning. And machine learning is an excellent example of one of the principles of the Mathematica, or the Wolfram language, which is automation. We're constantly striving to take domains which have previously required expertise in the domain to use, and automating the selection of methods and parameters so that anybody can use them. So here's an example using the classify superfunction. This is building a digit recognizer. And to do that, you simply give classify a table of images, and you say this image is a 2, this one's a 0, this one's a 3, and so forth. And now when I evaluate that, it automatically chooses the method and the parameters to build a recognizer. And now I have a function which will recognize handwritten digits. And you see I recognized a 3 here. Second huge swath of functionality is geographic computation. You can now compute things like asking it what is the nearest ocean to where I am currently and how far is it away. And there is full support for creating maps of all sorts and all projections and annotating them with arrows, with country polygons, and so forth. The geographics functionality is analogous to Mathematica's graphics functionality, and you can use entities like countries to specify country polygons to get their locations. You can use geographic coordinates and so forth. The geographic computation works all the way from global scope down to street level computations. And finally, I think this is one of the most exciting developments in version 10. That's geometric computation. There are now, you can now create geometric regions via Boolean operators with primitives and then do computations on those regions, like finding the exact area or centroids and so forth. And you can also deal with the messy kinds of polygons or regions that you find in the real world, like this country outline. Using that region and region nearest, it's trivially easy to make an interactive widget that tells you the nearest landfall to Italy if you're having engine problems and when you're sailing around Italy. But even more exciting is you can now compute over geometric regions. So for example, if I were to integrate 1 over xy contained in the Italy region, I get the area of that region. And that functionality is extended even further to a complete finite element modeling package, which is all neatly hidden behind NDSolve. So to solve Laplace's equation over the surface of the space shuttle, you simply specify that x, y, and z are elements of that region, and you get this result. So that's it. That's Mathematica version 10 in a very tiny nutshell. 700 plus new functions, cloud connected, and easier to use than ever before.